Tonight, there is one new clue that matters more than all the others. The anti-tail of 3i Atlas has flipped, and in the last day, it has swung into a line that now lies almost perfectly along your line of sight, from Earth to this interstellar object. On December 16th, just 3 days before closest approach, the strange, backward tail of 3i Atlas appears on the sky to be pointing straight back at you. If you click this video because of that, you're in exactly the right place. Over the past 24 to 48 hours, observers around the world have watched the anti-tail shift from one side of the orbit to the other, following the moment when Earth crossed the plane of Atlas's path. As they stacked images from different longitudes, they began to notice something unsettling and fascinating at the same time. The brightest part of the anti-tail now lies almost exactly on the narrow line that connects your planet to this visitor from another star. It is still hundreds of millions of miles away, but from where you sit, it looks like an arrow whose shaft has snapped into place. You have seen screenshots. You have read posts, comments, threads, and headlines. Some say it's just geometry. Some hint that this kind of alignment is too neat to ignore. You didn't click because you expect Hollywood explosions. You clicked because you want someone to unpack this one specific thing. What does it really mean right now that the anti-tail flipped and appears to point toward Earth? You also want a few other things while you're here. You want to know whether December 19th is going to be just another forgettable date on the calendar, or one of those quiet milestones that astronomers talk about for decades. You want to hear how serious people in this field are reacting, not just the loudest voices in your recommendation feed. And you want all of that explained in a way that respects your intelligence, calms your nerves, and still leaves you with that deep, familiar feeling of wonder you get when you let a space story carry you off to sleep. So let's be very clear, right at the beginning, about what you're going to get if you stay. By the time this story is finished, you will understand why the anti-tail of 3i Atlas flipped when it did, and how Earth's position turned that flip into a perfect-looking alignment. You will know what is actually happening along that line in space and what is not. You will walk through 3 realistic scenarios for December 19th, from the most boring to the most interesting, without any of them ending in catastrophe. And you will hear the strongest arguments both for and against the idea that what you are seeing could, in any way, resemble a designed formation. Along the way, you will also get something quieter but just as important: permission to enjoy this mystery without being owned by it. Because 3i Atlas really is strange enough to deserve your attention. Its brightness is lower than you'd expect for something so active. It glows with an eerie green coma rich in carbon molecules. It blasts out jets that push it off the path gravity alone would draw. It bathes itself in X-rays as the solar wind slams into its cloud of gas. And now, behind it, a stream of material holds together in a way that looks less like a random spray of dust and more like a structured wake trailing a ship. None of that, on its own, proves anything beyond an extreme case of natural physics. But when you hear that the tail has flipped, that the line behind this object now sits right along Earth's direction on the sky, and that this happens just as it approaches its closest point to our planet, you are not irrational for wanting to know more. You are paying attention. You are doing what humans have always done when the night sky changes in ways that feel uncomfortably precise. At the same time, you deserve more than vague reassurance or empty drama. You don't need to be told, "It's fine, don't worry about it," without explanation. And you don't need to be told, This changes everything by people who can't show their work. What you need is the middle path that you rarely get in your feed. A slow, careful walk through the facts, told by someone who is just as fascinated as you are, but not trying to scare you or sell you anything. So for a little while, you can let yourself step out of your day. You can leave the news, the bills, the traffic, the headlines, and step into something older and bigger. You are living at a moment when an object from another star system is sweeping past the inner solar system, close enough to map, bright enough to measure, and strange enough to challenge what we thought we knew. That alone is worth a few quiet minutes of your night. As you listen, you'll hear how far away 3i Atlas really is, how fast it's moving, and why every serious calculation says there is no impact corridor that leads to Earth. You'll hear what makes its tail so unusual, why the so-called anti-tail appears to aim at you, and how perspective in 3 dimensions can turn harmless alignment into something that looks like intention. You'll hear about the debates happening inside the community right now, from the most cautious voices to the ones willing to entertain possibilities at the edge of our comfort zone. And if, deep down, part of you clicked because that last phrase in the title, alien design, brushed against some old childhood feeling, some half-buried wish that there might be more mind out there in the dark, that part of you will not be mocked here. It will be listened to, examined, and treated with the same calm honesty as the physics. Right now, though, you only need to do one thing. Stay. Stay long enough for the noise in your head to settle. Stay long enough to hear how this alignment actually works. Stay long enough to walk from curiosity, through understanding, into a kind of peace with whatever the universe decides to be. 3 days left. The anti-tail has turned. On the sky, it points back toward you. Let's take a closer look at where 3i Atlas really is tonight, and what it is actually doing out there in the dark. Tonight, before you go any deeper into the mystery of the anti-tail, you deserve a clear, steady picture of where 3i Atlas actually is on December 16th. Not the speculation, not the noise, just the real-time cosmic snapshot. The one detail every serious observer checks before interpreting anything else. Right now, Atlas sits roughly 270 million kilometers from Earth, a little over 1.8 astronomical units away. That might sound abstract, so imagine this. If you placed Earth and Atlas on opposite sides of a giant circle, the space between them would still be wider than the entire orbit of Mars. That's how far we are from this visitor at this moment. No version of its path bends inward toward us. No correction, deviation, or gravitational quirk is pulling it closer. Its distance is enormous, stable, and getting larger. And that increase in distance is important, because Atlas has already passed perihelion, the closest point in its swing around the Sun, and it is now on the outward leg of its journey. When it skimmed near the Sun, it moved at about 246,000 kilometers per hour. You could circle Earth in minutes at that speed. But as of tonight, its velocity has dropped to roughly 220,000 kilometers per hour. That slow, steady decrease is exactly what you expect from an object riding a hyperbolic trajectory out of the solar system. You might think something so fast could swerve or veer dramatically, but that isn't how celestial mechanics work. High-speed travelers in space follow paths that are incredibly rigid. Atlas is no exception. If you look up tonight, though, you won't see it. Not even if you stare at the darkest patch of sky you can find. Its magnitude sits at around 11 to 12. Too dim for the unaided eye, too quiet to show itself the way a bright comet would. And this faintness is where the story gets interesting. Because for all its activity, the gas jets, the solar-wind interactions, the X-ray glow, Atlas is far dimmer than a comet with this level of output should be. This is the detail that astronomers and enthusiasts have been whispering about for days. Atlas is underluminous by a lot. Some estimates suggest it is 5 to 10 times fainter than a typical comet with comparable activity. Several observatories expected it to brighten after perihelion, even modestly, but instead, the magnitude stayed nearly fixed. The comet didn't flare, it didn't blossom, it didn't behave. And there are good reasons for that. Reasons that have nothing to do with danger and everything to do with chemistry. Most of its gas release is carbon dioxide, which reflects sunlight poorly compared to the water vapor that brightens many familiar comets. Its nucleus is coated in tholin, a deep, reddish organic material that absorbs more light than it throws back. And its dust output is low, meaning it doesn't scatter sunlight into a wide fan that the human eye can pick up easily. So what you get is a strange combination. A highly active comet that remains visually quiet. A comet shouting in physics, but whispering in visible light. And this is where the contrast becomes almost poetic. Because although the nucleus is faint to the point of feeling hidden, one part of Atlas refuses to blend into the dark, the anti-tail. While the sun-facing tail looks modest and diffuse, the anti-tail remains crisp, structured, and strangely persistent. Even small observatories in Chile, Italy, and New Mexico have remarked that the backward-facing structure is easier to track than the main body. That shouldn't happen. Comets born inside our solar system rarely keep a sharper anti-tail than their primary dust tail. Yet Atlas does. It's as if the light flows backward, illuminating the trail more strongly than the source. And that's where people begin to lean in. Not out of fear, the orbit is safe, confirmed, and locked in by multiple independent groups, but out of fascination. Because when a comet dims, you expect the details to blur. With Atlas, the opposite is happening. The dimmer the body becomes, the more visible its backward trail appears. This is why forums, observatories, and late-night watchers have all turned their attention to the same question. If the core is so faint, why is the anti-tail so pronounced? Tonight, you have the full picture. Atlas is far. It is slowing. It is faint for reasons we understand. And there is no version of reality in which it strikes Earth. But even with the fear removed, the curiosity remains. Because the most visible part of this visitor is the part that should not be this bright. So now that you know where Atlas stands on December 16th, its distance, its speed, its dimness, and its absolute lack of threat, you're ready to look at the one feature that refuses to behave like the rest. Now let's talk about the anti-tail, the part of Atlas that refused to behave. Now that you have a clear picture of where 3i Atlas stands tonight, you're ready to look at the single feature that has created the most discussion, the most late-night threads, and the most raised eyebrows. The anti-tail, not the main dust tail pushed away from the sun, the backward-facing line that shouldn't exist, yet somehow does. To understand why this has captured so much attention, you need the basic truth first. An anti-tail is not a reversed tail. It's not dust being pushed toward the sun. It's not a sign of propulsion, thrust, slowdown, steering, or anything acting against solar radiation. What looks like a backwards-pointing beam is actually a sheet of debris lying exactly along the comet's orbital plane. Most of the time, This sheet is invisible from Earth because you're looking at it from the side. But when Earth passes through the plane of the comet's orbit, like it has over the past week, that sheet brightens. And suddenly, what was flat and hidden becomes a line drawn across the sky. From your perspective, looks like the tail flipped. But that flip didn't happen in space. It happened because you moved. That's the standard explanation, the one astronomers have used for decades, and it works beautifully for most comets. But the anti-tail of 3I Atlas is not standard. This structure isn't faint or wispy. It isn't soft around the edges. It isn't fragile or patchy. It is sharp. It is long. It is bright relative to the faint core. Observatory reports over the last 72 hours have described the anti-tail using words like clean, crisp, coherent, and unexpectedly stable. That's not how anti-tails usually look. Some of the latest long exposure images show that the anti-tail extends farther than expected. In some frames, nearly 30% longer than early estimates. And rather than spreading out into a broad fan, the tail tapers into a narrow, high-contrast line with a teardrop shape. Wide at the base near the nucleus, narrowing smoothly into a single filament. Natural anti-tails can form teardrop shapes, but the smoothness of this one has made even experienced observers lean in, zoom in, and stare a little longer than usual. And then came the moment that changed the conversation. Not the flip itself, that was expected. But what happened after? Once Earth crossed the orbital plane, the anti-tail didn't just move to the other side of the comet's body. It slid into nearly perfect alignment with Earth's line of sight. On images taken from Spain, Chile, and New Mexico, the brightest portion of the anti-tail sights directly along the line connecting Atlas to our planet. The apparent alignment is striking. It looks engineered, even though it's not. It looks as if the trail is pointing directly back at you. And this is where curiosity tends to outrun comfort. But before anything spirals into unnecessary worry, hold on to the most important fact. Even if the anti-tail appears to aim at Earth, nothing in the physics supports any real directionality. At 1.8 AU away, no part of this dust sheet is moving toward Earth. No fragment is on an intercept path. Zero vector lines connect the anti-tail to our planet in any physical sense. What you see is alignment, not intention, geometry, not guidance. Still, the question remains, why does it look so clean? Why so defined? Why so structured? Part of the answer lies in the nature of the dust itself. Atlas may be shedding larger, more reflective fragments rather than fine powder. Larger particles tend to stay closer to the plane of the orbit, producing tighter formations. Some of these pieces may be coated in CO2 frost, which reflects sunlight more efficiently at certain angles. And long-term exposure to interstellar radiation may have hardened the outer shells of these fragments, giving them a glass-like quality that brightens when viewed edge-on. That edge-on perspective is exactly where Earth is now. When you look directly along the comet's orbital plane, even a modest line of debris will appear amplified. The same way a thin sheet of fog becomes opaque if you look through its depth rather than across its surface. But even with all of that known physics, the structure still stands out. The brightness gradient is smooth, the taper is symmetrical, the length has increased slightly over the past 3 days. And unlike most comets, Atlas's backward structure remains more stable than its sunward tail. This contrast, faint nucleus, strong anti-tail, is what makes people feel like they're witnessing something unusual. And unusual things attract speculation. One independent researcher recently wrote, "If someone wanted to hide probes inside a comet, this is the formation you would expect." It wasn't a claim. It wasn't a prediction. It was an observation about structure, a comment made half seriously, half speculatively. But it spread because it touched something people already felt. The anti-tail looks too clean to be ignored. But the moment you step back into the physics, the picture becomes calm again. This doesn't require anything artificial. It doesn't require design. Natural processes can produce exactly this kind of structure when viewed under the right angle with the right dust distribution. Atlas is dark, old, carbon-heavy, and chemically different from solar system comets. Its dust behaves differently. Its brightness behaves differently. And its anti-tail, though striking, still fits within the rules of orbital geometry. Yet none of that erases the strangeness of this moment. 3 days before closest approach, the only part of the comet that shouldn't appear as a line is the part that's most visible. And it's the part that now sits directly along your line of sight. The universe rarely draws straight lines unless it wants your attention. And now that it has your attention, there's only one question left. If the anti-tail looks structured, what exactly is inside that structure? Dust? Ice? Interstellar minerals? Something harder? Something older? To understand the anti-tail, you need to understand its building blocks. And that's where the real mystery begins. So what exactly is this swarm made of? By now, the anti-tail of 3I Atlas has taken shape in your mind. The bright, backward-facing streak that shouldn't exist, yet somehow does. You've seen how it flipped because Earth crossed the orbital plane. You've heard how it aligned almost perfectly with our line of sight. And you felt that subtle tightening of curiosity that happens whenever the universe draws a line sharper than you expect. So let's look closer at what that line is actually made of. The first thing to understand is simple. This anti-tail isn't a cloud of fine, soft dust drifting lazily behind the comet. It's not smoke, it's not fog, and it's not the kind of loose material you see in the sunward tails of most comets. Observations over the last few days show that Atlas's anti-tail has weight, literally. It's made of larger pieces, more reflective surfaces, and denser clumps of material that hold together better than the faint coma near the nucleus. Some of these fragments glint at specific wavelengths, hinting that they may be a mix of rock, CO2 ice, and possibly small metallic grains. These are not powder-like particles being blown apart by the sun. They're sturdier, heavier, more persistent. This brings us to the first lens through which scientists view the swarm, the natural debris field model. Under this model, Atlas behaved exactly as you'd expect an interstellar object to behave near perihelion as it swung past the sun. Its outer shell heated, cracked, and shed pieces of material built up over millions of years in space. When those fragments broke free, they were shaped by a familiar cocktail of forces: the gravity of the nucleus, the rotation of the object, the radiation pressure from sunlight, and the push of the solar wind. These forces don't scatter everything evenly. They stretch debris along the comet's path. They organize it by size and density. And they create precisely the kind of elongated, tapered structure you're seeing now. From this perspective, the anti-tail is simply a slice of the debris stream visible edge-on from Earth. The teardrop shape appears because the densest material stays closest to the nucleus, while lighter pieces stretch farther behind. If this is the whole explanation, then what you're seeing is the cosmic equivalent of dust settling behind a truck. Except the truck is older than the sun. and the dust has been sculpted by forces far more patient than gravity on Earth. But even within the natural explanation, one detail stands out. The swarm is not uniform. It doesn't fade gently from dense to sparse the way a Gaussian cloud would. Instead, it has edges, layers, regions where material appears thicker, followed by regions that look thin and clean. This organized asymmetry is what makes people stare longer. It's the feature that makes astronomers say, almost reluctantly, it looks organized. And organized is a powerful word. Which brings us to the second lens, the speculative one. The lens people use when they allow themselves to wonder what the universe might do if intelligence were involved. From this angle, you imagine a very different scenario. If you wanted to hide a small group of devices, probes, buoys, sensors, micro-observers, inside an interstellar object, you wouldn't scatter them randomly. You would put them where physics helps you. You would let them settle behind the main body, where they can share its trajectory without needing extra propulsion. You would keep them close enough to communicate, but spread out enough to widen their field of view. You would place them in a formation that resembles a school of fish following a whale, or a set of drones drifting behind a larger carrier. Look at the anti-tail through that speculative lens, and what do you see? A long, clean line. A stable taper. A grouping that is denser near the front and sparse toward the back. Something that looks less like chaos and more like pattern. This is why one researcher half-jokingly wrote, "If you wanted to hide a fleet, this is how you do it." He wasn't claiming that Atlas is carrying a fleet. He wasn't presenting evidence or suggesting fear. He was acknowledging what many people have quietly felt. The swarm looks more organized than you'd expect from random debris alone. But here is the line that matters most. The boundary between imagination and reality. There is no direct evidence that any fragment in the anti-tail is artificial. No signal, no acceleration anomalies, no motion that violates what physics predicts. Everything you see can be produced by natural processes. Fragmentation, rotation, geometry, particle size sorting, and the angle at which Earth is viewing the stream. The reason it looks organized isn't because someone organized it. It's because gravity is lazy but consistent, and it likes to arrange debris along paths that look intentional even when they're not. And here's something else worth remembering. Your brain loves patterns, especially when you're dealing with something that feels mysterious, something that came from another star, something that refuses to behave like the comets you grew up with. If you're slightly curious and slightly uneasy, your mind will connect dots that may not be connected at all. But curiosity isn't a flaw. It's why you're here. The swarm behind Atlas may be nothing more than a natural debris field seen under perfect geometry. Or it might be an unusually structured stream shaped by Atlas's unique chemistry, age, and interstellar history. Nothing in it threatens Earth. Nothing in its trajectory bends toward us. Nothing in its dynamics suggests active control. And yet, standing in front of a sky full of mysteries, you can still enjoy the question, why does it look so organized? Because that question is what makes you human, and it's what makes the universe interesting. But before the mind wanders too far, let's bring everything back to the ground. If the swarm looks heavy, sharp, or even a little intimidating, is any of it actually dangerous? Could any fragment break away, curve inward, and find its way toward Earth? Could the structure hide something that moves differently? It's time to put that question on the table clearly and calmly. So let's put this on the table clearly. Is any of this actually dangerous for Earth? Before we go any deeper into the mystery of 3i Atlas, before we talk about its colors, its chemistry, its X-rays, and the strange engine-like behavior inside its coma, you deserve something far more important: peace of mind. You've seen the images, you've heard the debates, you've watched that crisp anti-tail slide into alignment with Earth's line of sight. And somewhere inside you, even if you've tried to ignore it, a quiet question has been sitting there. Could this thing possibly hit us? The short answer, the real answer, is no. Not probably not. Not unlikely. The answer is no in the way that astronomers are comfortable saying no after double-checking the math, the physics, and the geometry hundreds of times. And here's why. 3i Atlas is a hyperbolic visitor. That means, mathematically, it's not bound to the Sun. Its orbital energy is positive, which is the orbital mechanics way of saying, this object came from outside the solar system, it's passing through, and it's leaving again. A hyperbolic object doesn't loop back. It doesn't circle around for a second try. It doesn't adjust into a new orbit. It enters, swings, and departs along a path shaped mostly by the Sun's gravity and its own initial momentum. You can't take a curve like that and suddenly bend it into a collision course with Earth without enormous, impossible amounts of energy. And Atlas has already passed its most important checkpoint: perihelion. It rounded the Sun, survived the intense heat, shed material, and is now on the outbound arc of its flight. If this object were ever going to do something dramatic or unpredictable, perihelion would have been the moment. Instead, it behaved like a natural volatile body. It heated, vented, cracked, and kept moving along its projected path. As of tonight, the closest it will ever get to Earth is about 1.8 to 2 astronomical units, roughly 270 million kilometers. That's not barely missing us. That's not threading the needle. That's so far that even the most extreme error bars in all the orbit models miss Earth by a cosmic mile. Think of it like throwing a dart from your backyard. Now imagine the wall you're aiming at isn't the side of your house. It's the side of a house 2 blocks away. You might not know exactly where on that distant wall the dart will land, but you know where it won't land: at your feet. That's how orbital uncertainty works. The dart may shift within a narrow corridor, but that corridor is nowhere near Earth. And 3i Atlas's corridor has been measured not by one group, but by many. NASA computed it. ESA computed it. University observatories computed it. Independent amateur astronomers, the ones with shockingly good equipment and no reason to hide anything, computed it. And every single one of those models says the same thing. No impact possible, no approach that even counts as close, no corridor that intersects Earth's space. But what about the outgassing? What about the jets inside the coma that push it slightly off its gravity-only path? Could these non-gravitational accelerations somehow nudge Atlas toward us? In theory, non-gravitational forces can adjust a comet's trajectory. They do it all the time. But there are limits. Hard, physical limits. Outgassing can shift a comet's motion by small amounts over long periods, not by millions of kilometers in a matter of days. Atlas would need a burst of perfectly directed energy on a scale that comets simply cannot produce, and nothing in its observations shows any such event. Not before perihelion, not during perihelion, not after. Then there's the fear that every space-curious viewer has at some point. What if everyone is wrong? What if there's a mistake nobody caught? Let's address that directly, with respect. In the modern era of astronomy, you cannot hide a threat like that. Not because governments are transparent, but because the sky is. Thousands of amateur observers track objects every night. They do their own calculations, post their own measurements, and run their own software. If any credible deviation appeared, it would be discussed, debated, torn apart, and published across the internet long before any agency had the chance to keep it quiet. The world has too many cameras, too many telescopes, too many independent researchers for anything this large and this bright to surprise us. You do not need a bunker. You just need a good pillow. Because here's the truth that matters most. Atlas is not a doomsday rock. It's not a threat. It's not a weapon. It's a traveler from another star system passing through our neighborhood. Even the weirdness, the anti-tail, the swarm, the unusual chemistry, none of it changes the simple geometry that keeps Earth completely out of harm's way. So you are safe. Your family is safe. Your planet is not in danger. And once that sinks in, you're free to enjoy the rest of the journey. The part where we get to explore this interstellar visitor not with fear, but with wonder. The real impact of 3i Atlas won't be physical. It will be intellectual. It will change how we think about comets, about interstellar debris, and maybe even about the way our solar system interacts with travelers from the deep, now that your mind can breathe, now that the tension has eased from your shoulders. You're ready for the most fascinating part of this story. What's actually inside Atlas? The color, the chemistry, the X-rays, the engine-like behavior in its core. So if it's not here to kill us, what is this strange visitor actually made of? Now that you know you're safe, you can finally do what every true sky watcher wants. Lean in closer. Forget the anxiety for a moment. Forget the anti-tail pointing toward Earth. Let's talk about what 3i Atlas actually is on the inside. Because the deeper you go, the stranger this object becomes. And the more you learn, the more it feels like you're studying something from a science fiction manual that somehow escaped into real life. Start with the color, the thing that has confused even seasoned astronomers. When Atlas first entered the inner solar system, it looked like most interstellar bodies. Dark red, almost rusty. That reddish-brown hue comes from tholin, a kind of organic soot made over millions of years as cosmic rays strike the surface of an icy body drifting between stars. Tholin-rich surfaces absorb light, especially blue and green wavelengths. That's why these objects tend to look dull, muted, almost bruised. But as Atlas approached the sun, something dramatic happened. The heat stripped away that ancient outer skin. The tholin layer burned off, sublimated, and peeled back. And underneath, something fresh appeared. Material that hadn't seen sunlight since long before Earth existed. Suddenly, the comet glowed green. Not the soft green you see in a glow stick, a sharper green, a chemical green. That green tells you exactly what Atlas is made of. Carbon molecules like C2 and CO2 that fluoresce when hit by ultraviolet light. When you see that emerald glow, you're not just seeing color. You're seeing chemistry from another star system being shaken awake. Next, the X-rays. Yes, Atlas emits X-rays. And not a little, a lot. Enough that observatories flagged it within hours. Here's why. When a comet with a thick coma passes through the solar wind, high-energy ions crash into neutral atoms around the nucleus. Those collisions create flashes of X-ray light. If the coma is dense enough, the effect becomes bright, like a thin halo of invisible lightning wrapped around the comet. For Atlas to shine like this, its coma must be enormous. A big, turbulent cloud of gas and dust interacting violently with the solar wind. That tells you two things. First, Atlas is shedding material aggressively. Second, the sun is hitting it hard. And then comes the weird part. When astronomers looked deeper into the spectroscopic fingerprints, they found something unexpected. Instead of a water-rich comet, like the ones we grew up with in the solar system, Atlas is dominated by CO2. Water vapor is present, but faint. On the other hand, methanol shows up clearly. Hydrogen cyanide appears, and the Ni-Fe ratio sits far outside the usual solar system range. Nickel vapor stronger than iron is not what you're supposed to see. Imagine slicing into a rock and finding streaks of metal and pockets of frozen volatile gases woven together like a marble cake. That's Atlas. It's chaotic, not layered, not simple. A violent mixture of ices and heavy elements that suggests a birthplace far from anything we understand. Maybe in a colder system, or around a metal-rich star, or inside some region of interstellar turbulence that simply doesn't exist near us. But nothing about Atlas's interior is more surprising than its engine. Not an engine with gears or valves or pipes. A natural engine, but one that behaves uncannily like a machine. Inside Atlas are pockets of trapped volatiles. As sunlight reaches them, they heat unevenly. Some pockets burst, some jets ignite. Some areas remain cool. Gas shoots out in narrow beams, then disappears, then comes back again somewhere else. Each burst creates a push, a shove, a tiny blast of natural thrust. Because the nucleus is lumpy, irregular, asymmetric, those jets don't balance each other. That imbalance turns Atlas into a kind of chemical thruster drifting through space. It sputters, it jerks, it accelerates in directions no simple gravity model can predict. And that's why astronomers measure not only the usual outward acceleration from outgassing, but sideways forces too. A1, A2, A3, all showing meaningful values, all proving Atlas is pushing itself, even if only a little. This is the part that catches people's imaginations. This is where the alien design whispers begin. Because when an object produces asymmetric thrust, when it glows green, when it emits X-rays, when it carries a strange metal signature, when it flips an anti-tail that looks structured, you start to wonder. Not in a fearful way, not in a panicked way, but in that quiet, late-night way that science-minded adults wonder when something doesn't quite fit the template. Could such a chemical engine be used by something intelligent? Sure, in theory. Would it make sense to hide small devices inside something like this? Also possible, in theory. But here's the grounding truth. Nature doesn't need help to build engines. It's been doing it for billions of years. Every volcanic vent, every geyser, every jet on a comet is a natural thruster. And everything Atlas does still fits within the physics we know. Nothing breaks the rules. Nothing requires a designer. But the resemblance, the feel, is enough to keep your imagination awake. And that's exactly the balance this moment gives you. Science that's solid, weirdness that's undeniable, mystery that's real, but not frightening. Because Atlas doesn't behave like comets in our solar system. It behaves like something that was shaped by different stars, different pressures, different histories. Its chemistry is a message. Its jets are a story. Its glow is a clue. And its interior is a living map of a place we've never seen. And that's why Atlas matters. Not because it threatens Earth, but because it carries the recipe of another world. To really understand how strange Atlas is, you need to see it in context, among the few other interstellar visitors we've ever met. You've already seen how strange 3I Atlas is on the inside. The marble cake chemistry, the emerald glow, the X-ray halo, the natural engine sputtering inside its fractured core. But there's another layer of the story that matters just as much: context. Because Atlas didn't arrive into an empty chapter. It's the third visitor in a brand new cosmic category: interstellar objects. A category that didn't even exist in textbooks when most of us were growing up. And when you compare Atlas to the two visitors before it, the picture becomes even clearer. This is the strangest one yet. Start here. Atlas is not the first messenger from another star. Before it came two others, and each one rewrote the rules. The first was Oumuamua, back in 2017. You probably remember the headlines. The cigar-shaped object, the pancake-shaped object, the long, thin blade that spun silently through the solar system without a tail, without a coma, without behaving the way anything icy was supposed to behave. No gas, no dust, nothing to show it was shedding material. And yet, it accelerated. Just a little. Just enough to confuse everyone who tried to model its path. You could watch the world's best orbital dynamicists folding their arms, leaning back, raising their eyebrows. Then A.V. Loeb stepped in and said out loud what many were whispering. This doesn't look like a comet. It looks like a probe. Not proof, not certainty, but a reminder that the universe sometimes leaves the doors slightly open to the unexpected. Then came Borisov in 2019, the opposite of Oumuamua in almost every way. If Oumuamua was a blade, Borisov was a snowball. Dusty, water-rich. A classic comet, the kind you'd expect to drift in from the Oort cloud. Except it wasn't from here. It was the first interstellar object that behaved normally. A tourist passing through. A comet that made astronomers exhale with relief. Okay, so interstellar visitors can be ordinary. And then, in 2025, the third arrived. 3I Atlas, the hybrid. Part comet, part anomaly. A visitor that refuses to sit neatly in either category. You can think of it like this. If Borisov was familiar and Oumuamua was bizarre, Atlas is the uneasy middle, familiar enough to track, strange enough to make you lean forward. Just look at the combination. Like Borisov, it has a coma. It vents gas. It glows. It sheds material. But like Oumuamua, it experiences strong non-gravitational acceleration. It jerks sideways. It produces thrust from asymmetric jets. It doesn't glide smoothly. It fights its own path. Then come the details no one expected. Atlas has the clearest anti-tail ever observed in an interstellar object. Not a faint smudge, a crisp, beam-like structure that flipped as Earth crossed the orbital plane. You can draw a line along it. You can trace its curve. You can watch the teardrop shape stay intact as the comet rotates. Then there's the color, that striking green. Borisov never showed that. Oumuamua couldn't show it because it had no coma. Atlas does, because it shed just enough of its outer shell to reveal a layer rich in carbon molecules and volatile ices. For a few weeks, it let us see material that has been sealed away for billions of years. And then the Ni-Fe ratio, one of its strangest signatures. Most comets in our solar system follow a predictable chemical recipe. But Atlas's recipe isn't from our kitchen. It's as if someone switched the proportions, adding far more nickel vapor than iron. Not enough to suggest machining or metallurgy, nothing artificial. But enough to say, This object grew up somewhere that does not play by our rules. This is what makes Atlas special. It carries pieces of another world, pieces that behave in ways our models didn't expect. It's a textbook from somewhere else, drifting right past Earth at a moment when humanity actually has the tools to read it. And think about the timing for a second. When Oumuamua passed through in 2017, we weren't ready. When Borisov visited in 2019, we were still learning how to interpret interstellar chemistry. But Atlas arrives in 2025, a year when we have JWST, high-power amateur imaging, better spectrographs, faster data sharing, and millions of eyes paying attention. You are living in the first era in human history where the universe is sending postcards from other star systems. And you're able to understand what you're looking at. Not just watch it drift by. Understand it. The timing is almost poetic. And here's the part that hits differently when you're in your 40s or 50s. You remember a time when interstellar objects were science fiction. You remember a time when visitors from another star were just a chapter in old astronomy books, usually filed under hypothetical. And now, 3 of them within less than a decade. 3 pages turned in a brand new cosmic encyclopedia. Think of it this way. If the universe writes its history one visitor at a time, Atlas is the most detailed chapter yet. Because this time, you're not watching a smooth rock glide silently through space like Oumuamua. You're not watching a standard comet like Borisov. You're watching something that behaves like the child of both. The swirl of familiar and unfamiliar, natural and odd, predictable and chaotic. A body that carries the chemistry of unfamiliar stars, the physics of unfamiliar environments, and the scars of a journey across interstellar space. And the longer you look at it, the more one truth becomes obvious. 3i Atlas behaves like something caught between 2 worlds. Part traveler, part messenger, part comet, part puzzle. And that's why December 19th feels bigger than a simple, closest approach. It feels like a moment only a small number of generations in human history will get. The moment Earth stands close enough to examine an object born under another sky. You're not just watching astronomy news. You're living in the early chapters of a story scientists will still be teaching 100 years from now. And if Atlas looks like a message, the next question is obvious. Where did this message come from? Let's turn that page and trace Atlas back to the place it was born. After meeting the first 2 interstellar visitors, Oumuamua the Blade and Borisov the Tourist, and after seeing how Atlas fits somewhere in between, there's a natural next question. Maybe the biggest one of all. Where did this thing come from? Because nothing about 3i Atlas is local. Nothing about it is familiar. And nothing about it feels like the product of our solar system. If you want the full answer, you have to rewind the clock. Not thousands of years, not millions, but billions. You have to picture a time before Earth, before the sun, before our neighborhood of planets even existed. And in that darkness, you have to imagine the place where Atlas was born. Astronomers begin the trail with its hyperbolic path, that long, sweeping curve that proves it's not bound to our sun. When you trace that trajectory backward, project it far beyond the gravitational ripples of the planets, and aim it into deep space, it points toward a region near the constellation Serpens, a place rich in young stars, a place filled with the shrapnel of ancient supernovae, a place where stellar nurseries and stellar graveyards sit side by side. It doesn't match the incoming path of Oumuamua, and it doesn't trace back to Borisov's home region either. Atlas comes from its own unique origin. To understand how something like Atlas could form, you have to picture a star system in its chaotic youth. A place where gravity is still carving planets, where gas giants migrate inward and outward, where moons slam into protoplanets, and where debris flies like sparks from a welding torch. In the early years of any star system, chaos is a feature, not a bug. Somewhere in that distant place, billions of years ago, two worlds may have collided. Or a growing planet may have flung smaller bodies outward using its gravity like a slingshot. Or a shock wave from a nearby supernova may have blasted through the system, kicking loose a swarm of icy objects and sending them drifting into the dark. 3I Atlas was likely one of those bodies, a fragment of an ancient world shattered long before Earth formed. The chemistry inside it suggests a birth in a region colder and more volatile rich than our own early solar system. The strange nickel-to-iron ratio hints at a metallic environment different from anything we see here. Everything about Atlas whispers, "I was made somewhere else." Its age backs that up. The material in Atlas is old, older than Earth, older than the Sun. Some estimates suggest 5 to 7 billion years, meaning this object carries the fingerprints of a star system from an era long before ours emerged from its own collapsing cloud. Imagine holding a relic older than your planet, a time capsule from before the Earth existed. That's what Atlas is. For most of its life, Atlas didn't travel dramatically. It drifted. It wandered through the interstellar medium, passing through cold molecular clouds where dust clung to it like frost. Over time, cosmic rays etched microscopic scars across its surface, carving the outer crust into something tough, dark, and red. The tholin layer we saw when it first approached the sun. For millions of years, maybe hundreds of millions, it drifted in silence. No planets, no stars, no sunlight, just the endless night between systems. Then, at some point, maybe 50 million years ago, maybe 200, something bumped into it. Not enough to destroy it, but enough to chip pieces off. Enough to create a swarm, enough to leave a fossilized debris field that is still traveling with it today. A collision in a dark nebula, preserved like a prehistoric bruise. When you look at Atlas's anti-tail, the one that flipped, the one that aligns with Earth, you might be seeing the remains of that ancient impact. A debris field older than every mountain on Earth. An echo of violence from a time and place no human will ever visit. And yet, in the tradition of cosmic storytelling, there's always one more possibility. Speculative, imaginative, and very human. Some researchers wonder whether interstellar objects might carry traces of technology from civilizations long gone. Not living civilizations, but relics, artifacts, abandoned structures. The universe is old enough for entire technological species to rise and fall before Earth existed. Could a shattered fragment of some ancient orbiting structure be hiding inside Atlas? Unlikely, unsupported, but not impossible in the abstract sense. These thoughts don't explain Atlas. They simply reflect the way our species uses imagination to illuminate the unknown. The truth remains grounded. Everything observed in Atlas fits natural physics. The swarm behaves like debris. The jets behave like chemical thrust. The green glow behaves like carbon chemistry. There is no signal, no artificial motion, no anomaly that breaks the universe. But speculation has its place, especially when the real story is vast enough to hold it. Because what really matters isn't whether Atlas carries a message from an ancient civilization. What matters is that Atlas is a message, written in chemistry, in motion, in the scars of its surface. It tells us about the conditions that existed around another sun. It tells us what materials were present. It gives us a sample of a world that no longer exists. Think about that. You're not just watching a comet swing past Earth. You're watching a survivor from an era before the solar system was born. You're listening to a traveler older than the sun. And by pure luck, by pure timing, it arrived now. At a moment when humanity finally has the telescopes, the instruments, the digital networks, and the global attention to study it properly. Had Atlas passed through 1,000 years ago, no one would have known. 500 years ago, it would have been a faint light. 50 years ago, we would have barely captured it. But today, we can read it, line by line, atom by atom, clue by clue. And that sets the stage for the question everyone is waiting for. We know where Atlas came from. We know what shaped it, scarred it, colored it, and carved the swarm that trails behind it. Now comes the part that brought you here, the part that made December 19th circle itself on your mental calendar. So now that we know where Atlas came from, what exactly will happen on December 19th? Now that you've followed Atlas across billions of years, from its birthplace near Serpens, through supernova shockwaves, through the dark between the stars, and finally into our solar system. You've arrived at the moment everyone keeps asking about. What will actually happen on December 19th? Not the imagined version, not the doom-loaded version that floats around the internet. The real, physically possible, scientifically grounded version. December 19th is simply the day Atlas reaches its point of closest approach to Earth. It's not close in the way movies use the word close, but it's close enough for every telescope, professional and amateur, to turn toward it. Close enough for us to measure. Close enough for us to learn something new. And close enough to make this date feel like a small holiday for anyone who loves the sky. So let's break down the 3 scenarios astronomers actually consider. The 3 things that could realistically happen. The first scenario is the quiet one, but also the most meaningful. Nothing dramatic happens. Atlas passes overhead. No flare, no explosion, no sudden jet ignition. It simply continues along its outbound hyperbolic arc, shedding a little material, glowing faintly green, trailing its swarm behind it. This is the scenario NASA expects. And far from being disappointing, it's powerful. Because it gives us an uninterrupted, perfectly stable data set. We get clean measurements of brightness, clean measurements of its motion, clean readings of its chemical composition after perihelion. Sometimes, nothing eventful is exactly what scientists hope for, because it means the universe is letting them take notes without interruption. But December 19th could also bring a second scenario, one that's still safe, still gentle, but visually interesting. A small flare or outburst. Atlas is rich in CO2, and that kind of ice can trap gas deep inside the nucleus. If one of those pockets bursts, it could release a new jet. The coma might brighten, the anti-tail might sharpen, the swarm might rearrange just a little. You might see the astronomy community light up online as images start appearing from backyard telescopes and major observatories. Not fear, excitement. Think of it as cosmic fireworks, harmless, predictable, but beautiful if they happen. Then there's the third scenario, the one that has generated the most curiosity, a brief alignment event. For a short window, Earth, Atlas, and the Sun could line up in such a way that the anti-tail appears perfectly straight, not curved, not feathered. A clean beam of reflected dust and ice, shining along our line of sight. For a moment, it might look like a pointer, a signal, or even a laser. Not because Atlas is doing anything intentional, but because geometry occasionally gets poetic. This is the kind of moment that reminds you why astronomy feels spiritual. The sky creates shapes no one asked for, signs no one designed, and scenes that look almost symbolic. And now for the most important part. All three scenarios are completely safe. None of them involve a collision. None of them include a fragmentation that could redirect debris toward Earth. None of them introduce any force capable of altering Atlas's hyperbolic path. No vector points toward us. No jet is strong enough to change anything at this distance. No swarm fragment is anywhere near our orbital lane. The only thing December 19th brings is clarity, a chance to refine everything we've learned up to this point. That's what makes the day special. Not danger, not drama, but the chance to watch an interstellar visitor as it settles into the most predictable part of its journey, allowing us to measure things we couldn't measure before. On December 19th, astronomers will finally be able to confirm the true structure of the swarm. They'll measure the direction and magnitude of Atlas's non-gravitational acceleration as it stabilizes after perihelion. They'll watch how the jets behave in cooler conditions. They'll map the velocity of escaping gas. They'll test whether the green glow fades at the rate models predict. In other words, December 19th is the day the fog clears. And here's something you might not expect. Once people hear the words "no impact," their minds shift gears. The fear loosens its grip. The curiosity takes over. And that's exactly the state you want to be in, especially if you're a viewer who loves to listen late at night, looking for something that feeds the intellect but calms the nerves. Because the truth is simple. The closest approach of an interstellar visitor is not a threat. It's a mirror. It reflects who we are, a species wired to fear first, but built to wonder afterward. We expected fear. What we got is perspective. On December 19th, nothing catastrophic happens. But something meaningful does. We learn, we observe, we understand a little more about the universe that built us. And once you remove the fear, once your shoulders drop and your breathing steadies, you're finally ready to ask the next question, the one that sits beneath all of this. If Atlas isn't here to destroy us, maybe it's here to remind us who we are. By now, you've walked with Atlas through chemistry, color, thrust, age, and origin. You've seen the swarm, the green glow, the engine-like jets, the ancient scars from another star, and somewhere in the back of your mind, one question has been building. Not because you're gullible, but because you're human. What if this isn't just a comet? You're not the only one asking. Across observatories, research labs, podcasts, and late-night astronomy forums, a debate has been running in parallel, quiet but alive, cautious but honest. And Atlas, more than any visitor before it, has pushed that debate into the spotlight. On one side is the mainstream camp, NASA, most professional astronomers, and the conservative half of the scientific world. Their stance is clear. 3I Atlas is a highly unusual interstellar comet. Not ordinary, not simple, not easy to model, but still natural. They look at the green glow and see carbon chemistry cracking open after billions of years. They look at the X-rays and see textbook charge exchange with the solar wind. They look at the non-gravitational acceleration and see a nucleus shaped like a broken potato blasting jets in uneven bursts. They look at the anti-tail, even its crisp alignment, and see a geometric effect amplified by large debris clumps. Their message is steady, calming, and grounded. Weird does not mean artificial, not yet. Then there's the other side, the provocative camp. A small group, but not a fringe group, led most publicly by Avi Loeb and joined quietly by a handful of open-minded researchers. Their stance is very different. We should not rule out a technological origin too quickly, not because they believe Atlas is artificial, but because our sample size is tiny. 3 interstellar objects, 3 wildly different behaviors, 3 reminders that our intuition is built on a solar system that is not representative of the galaxy. This side points out that the anti-tail looks unusually structured for a debris field. They highlight the Niefe ratio that sits far outside solar system norms. They note the strange timing of data glitches from a few spacecraft observing the coma. They mention the quietness of Maven's solar wind readings around certain observation windows. They don't claim conspiracy. They point to coincidence, clustering, odd alignments. If we are willing to invent new dark matter models to explain anomalies, they argue, we should be willing to consider technology as a hypothesis too. This is not sensationalism, it's philosophical consistency. The universe is old. Civilizations could rise and fall before the Earth formed. Objects like Atlas could carry debris from places where minds once existed. Not proof, just possibility. And floating above both camps is a principle every scientist agrees with. Whether they lean cautious or bold, Carl Sagan's standard: extraordinary claims require extraordinary evidence. That sentence is the referee in this debate. It doesn't say don't imagine, doesn't say don't explore. It simply says, if you're going to claim intelligence, bring evidence that intelligence left fingerprints. So far, Atlas hasn't. No signals, no controlled maneuvers, no acceleration profiles that defy physics, only patterns, compelling, beautiful, strange, but still explainable by natural forces. And this is where you, the listener, start to feel something the debate rarely acknowledges: relief. Because you don't actually want the world to choose sides right now. What you want, what most Skywatchers your age want, is to hear the whole argument without being told which part to believe. And the truth is, both sides matter. The conservative camp keeps us grounded, reminding us that nature is capable of strangeness we haven't fully cataloged yet. They stop us from jumping too quickly to extraordinary conclusions just because something looks off. The provocative camp keeps us honest, reminding us that curiosity doesn't need permission, and that shutting down questions is unscientific. They push against intellectual laziness. They widen the field of possibility. Both sides are necessary. Both sides protect something important, and no one in this debate is stupid. They're just standing at different distances from the same mystery. Atlas isn't the first object to test this tension. Oumuamua did it in 2017 with its shape and acceleration. Atlas is doing it now with its chemistry and swarm. And whether you lean skeptical or speculative, you're part of the same conversation. Science has never been a verdict. It has always been a dialogue. And if you're still here, still listening, still thinking, still weighing both sides, that tells you something about yourself. You're not looking for confirmation bias. You're looking for understanding. You're holding curiosity in one hand and skepticism in the other, without dropping either. And that's what this moment demands. Now comes the part where we face the question in the title head on. Not as clickbait, not as a trap, but as a genuine prompt for reflection. So let's talk honestly about that phrase in the title. Is this the alien design? You've stayed with this story for almost an hour now. You've heard the science, the anomalies, the debates, the mysteries, and the possibilities. And at this point, There's no reason to avoid the question printed right there in the title. Let's read it the way the night sky would read it. Slowly, clearly, without rushing. 3-eye Atlas. 3 days, anti-tail flipped, pointing at Earth. Is this the alien design? So what does that question really mean? And what is it actually asking? Let's begin with the most straightforward layer, the object itself. With every observation we've collected so far, the truth is steady. There is no radio signal coming from Atlas. There is no mechanical structure hiding inside the coma. There is no coded pulse, no stabilization pattern, no piece of behavior that breaks the laws of natural physics. Everything we've seen, the green glow, the X-rays, the jets, the swarm, the anti-tail flipping into alignment, can be explained by extreme but natural processes. Not perfectly, not comfortably, but naturally. So the honest answer is simple. We do not have enough evidence to say Atlas is alien technology. And if anyone claimed that outright right now, they wouldn't be telling you the truth. But that's only the first layer. Because the phrase alien design is bigger than the object. On the second layer, the question becomes a test of how we look at the universe itself. When you ask, is it alien? The real questions underneath are we alone? Is anyone else out there building things? Does intelligence exist somewhere beyond our sky? Atlas, in that sense, isn't just a comet or a visitor. It becomes a catalyst, a spark that forces humanity to turn and face the oldest question we've ever asked. We project our hopes and our fears onto it. We stare at the anti-tail and wonder if geometry is trying to speak. We watch the green glow and imagine a message. Not because the object is asking for that attention, but because we are. The question, is this alien design, becomes shorthand for, is the universe more crowded than we thought? And that brings us to the third, deepest layer, the part no instrument can measure. Alien design becomes a mirror. If you're someone who desperately wants Atlas to be artificial, maybe that desire comes from a longing for revelation, a craving for something bigger and more meaningful than the routines of everyday life. You want the universe to surprise you. You want a plot twist. You want proof that you're living in a story larger than the one on Earth. If you're someone who fears the idea of alien design, maybe that fear comes from feeling small, vulnerable, or unprepared for a universe that doesn't revolve around us. Maybe the thought of something older, smarter, or more capable makes the world feel unstable. Either way, hope or fear, Atlas reflects something about us. Not about aliens, about humans, about the emotional state of a civilization that's advanced enough to look outward, but still young enough to feel alone. And that's where the heart of this video sits. Because you don't need Atlas to be artificial for it to matter. You don't need a spaceship hidden inside its core. You don't need a message encoded in the swarm. Nature, all by itself, is already strange enough to keep you awake, and gentle enough to let you fall asleep again. That's the beauty of asking the question seriously without falling into obsession. You get to keep the door open, wide open, for the possibility that the universe holds other minds, other builders, other stories. But you also teach yourself the discipline of evidence. You learn not to leap without a landing place. You learn to balance imagination with clarity. And here's the part I know resonates deeply with viewers like you. Viewers in their 40s, 50s, and beyond. You've lived through hype cycles. You've seen doomsday predictions come and go. You've watched rumors rise and fall. You've learned to enjoy mystery without being consumed by it. You don't need certainty to appreciate wonder, you just need honesty. And the honest truth is this: we don't just discover the universe, we discover ourselves in the way we talk about it. When we ask, "Is this the alien design?" we're not really asking about a comet. We're asking why we want the universe to speak and what we hope it will say. Maybe the strangest thing isn't whether Atlas is artificial. Maybe the strangest thing is how ready we are, as a species, to believe that meaning might arrive on a green glowing rock from another star. In the end, the alien design might not be out there in the tail of a comet. It might be right here, in the way your mind is wired to search for meaning, pattern, belonging, and connection. And that's the real payoff. You don't need a yes or no answer to feel satisfied. The value wasn't in proving aliens or disproving them. It was in the journey, in the thinking, the imagining, the wondering that you've been doing all along. So before the video comes to rest, and before you fall asleep tonight, it's time to step gently out of the debate and into something quieter. Something that brings the whole story back to you. So before you fall asleep tonight, let's step back from Atlas and look at where you are in all of this. Take one slow breath. We're 3 days away from the closest approach. Just 3 quiet nights. And you've just spent nearly an hour traveling with Atlas in your mind, across millions of years, across interstellar clouds, across colors and jets and debates and possibilities. You followed it from the day it left its birth system to the moment it drifts quietly past ours. So before this night ends, let's gather everything into something soft, simple, and easy to hold. 3 things. That's all your mind needs right now. First, 3i Atlas will not hit Earth. It cannot turn, cannot curve, cannot suddenly aim at us. Its path is already written, and that path stays far, far away. Second, Atlas is strange, wonderfully strange. Strange in a way that reminds you the universe is infinitely more creative than our headlines. It has a green heart, a broken surface, a swarm trailing behind it, and a story older than our sun. Third, Atlas makes us ask big questions, but it does not demand that we fear it. And now, we're going to shift the focus, away from comets, away from data, and toward you. Picture this: a quiet bedroom, a long day behind you. You're lying on your back, maybe with one arm tucked under the pillow. The room is dim, maybe lit only by a warm lamp or the glow of your screen. The world outside is dark, and the sky above your ceiling is even darker. While you rest, somewhere far beyond that roof, Atlas is racing through interstellar blackness at hundreds of thousands of miles per hour. Earth is orbiting the sun at 30 kilometers per second. The sun is orbiting the galaxy at 500,000 miles per hour. Our galaxy is falling toward the Virgo cluster at even higher speeds. Everything out there is moving. Everything out there is rushing. Everything out there is loud in its own cosmic way. But you are the only thing in this whole story who is allowed to slow down. Right now, while Atlas sprints through the night, you are allowed to be still. Let me say this clearly, gently, one more time. You are not in danger. Your family is not in danger. This comet is not here to threaten anything on this planet. The only impact it will leave is the way it made you think, the way it stretched your imagination, the way it reminded you that the universe is bigger than your worries. Tomorrow, when someone mentions that weird comet, you'll know more than the headline. You'll know the anti-tail, the swarm, the chemical engine, the debates, the mysteries. You'll know the truth behind the noise. And that truth feels like a secret held gently in your hands. So now, let the numbers fade. Let the diagrams fade. Let the jets, the X-rays, the angles, the heavy elements, the cosmic history all dissolve into a soft, dark sky. Imagine that sky above you now. A wide, open black. A few small, cold stars. And far away, almost invisible, Atlas. A tiny emerald dot moving through silence. It doesn't need your attention anymore. Doesn't need your worry. Doesn't need anything from you. You can let it go. And here's the part most people never hear. You don't have to watch the sky. You don't have to check the news. You don't have to follow every update. There are thousands of people doing that for you. Astronomers with giant telescopes, graduate students staring at screens at 2 a.m., radio dishes listening for whispers, amateurs with backyard observatories. And yes, this channel. We'll keep an eye on it. You don't have to. All you have to do tonight is rest. If you ever want to hear what happened after December 19th, you can subscribe, or you can simply come back whenever you feel curious again. There's no pressure, no urgency. Think of this place like a small cafe by the edge of the universe. A spot you can return to whenever your mind needs quiet. The sky can be loud. Life can be loud. But here it doesn't have to be. Before we close this night, here is the truth wrapped in its simplest form. The universe is large. You are small, but you are safe. Atlas is a visitor, a traveler passing through our neighborhood on its way to nowhere in particular. It will come, it will go. It will leave behind data, curiosity, and conversations. And you will still be here, on a small, warm world, held tight by gravity, surrounded by air, and protected by nothing more complicated than the simple fact that you exist in exactly the right place. You don't need to take care of the universe tonight. You don't need to understand everything. You don't need to stay awake. You just need to breathe, to let your muscles soften, to let your mind float, to let the day fall away. Tonight, an interstellar traveler is passing through our cosmic neighborhood. You don't have to chase it. You don't have to solve it. You just have to rest. We started this video asking if Atlas might be an alien design, but we end here with something quieter. The realization that you, lying here, breathing slowly in the dark, are already part of a universe stranger and more beautiful than any headline. So now, 3 days to go. You're safe. We'll watch the sky for you. Good night.